Hello and welcome to this video on our Chapter 3 review. So this is our quadratic functions review. So I'm going to be going through some of these questions and then some of them I won't. You can work on those questions on your own. So number 1, it says for each of the following determine the number of x-intercepts, the equation for the axis of symmetry, and the domain and the range. And for this one we got this function here. I can see that that is written in vertex form. So it's in vertex form where this is my P, that's my Q, and that's my A. So I got my A, my P, and my Q. Now you guys should know what those characteristics give you, the A, the P, and the Q. So A, that gave us our vertical stretch, our reflection in the x-axis. It also told us congruency. It told us how wide or how narrow. You should know all of those. The P, it told us the horizontal translation, told us the x coordinate of the vertex, and the axis of symmetry. And then Q, it told us vertical translation up and down. It also told us the y coordinate of the vertex, and because it's the y coordinate of the vertex, it also tells us the max or the min, and it also affects the range. Okay, so you should know kind of all of those characteristics. So answering these questions though, we first want to find the number of x-intercepts. Now I'm going to draw a little picture of this graph. So I know my vertex actually should be minus minus. So our vertex is at -5 and 6. So if I was over at say -5, I'm going to be 6 up. That's where our vertex is. And then the negative here tells me that it's going to point down. So I know it's going to look something like this. I'm just getting a kind of rough sketch to be able to answer the questions. So the first part, the number of x-intercepts, I can see from my graph that it crosses once, twice. So we got 2 x-intercepts. Second part is the equation for the axis of symmetry. Okay, and that's going to occur at the p-value there. So that's x equals -5. Then we also need to find the domain. So domain, we'll just use the letter D. It's x, given that. Always start out with that. And I can see x, and for all quadratic functions, you're getting all of the x values. So it's just x is an element of the real numbers. So it's like that every single time unless it's a application question. And then the last one is the range. We'll use the letter R. And I can see from my graph, I only go as high as this 6 and everything is below that. So my range is going to be y, given that. Y has to be less than or equal to that highest point, which was 6. And y is an element of the real numbers. Okay, so there's part A. Then you guys can work on part B on your own. Number 2 says for each of the following, determine the coordinates of the vertex and whether the graph has a max or a min value. So again, this one is written in vertex form. So I can see my vertex is at 3 and -7. So I'm just going to write that. Okay, so there's one part to our answer. We know what the vertex is. Then we had to state whether it had a max or a min value. So in this case, the A value right here in front is negative. So I'm going to say A is less than 0, which means A is negative. Therefore, it's going to open downwards. And if it opens downwards, I can see from that I'm going to have a maximum. Okay, and then again, for part B, you guys can work on that on your own. Moving to number 3, here we're going to do A. So it says sketch each of the following functions, label the vertex and axis of symmetry. So again, this one is written in vertex form. So I can see my vertex is going to be at the point. It's -1 because it's always kind of opposite of what you see there. It goes x minus minus. 1, and those two minuses gave me a plus. And then the end term, there's nothing there, so it's like a plus 0. So the vertex is going to be at -1 and 0. And then I'm going to plot that point here first. So I'm going to go to -1 at a height of 0, so right there. And then to get some other points on the graph, I'm going to make a table of values. I know that I'm centered at the vertex there at -1 and 0, so I'm going to put that in the middle, and then I'm going to find some points on either side of it. Okay, so let's do 0 here first. It's going to be -4 times, so I'm just taking this function and I'm entering in a 0 for x. 0 plus 1 squared, and when I do that calculation, in the inside of the brackets there, 0 plus 1 is just 1, 1 squared is 1, 1 times -4, we get -4. Okay, and I know a parabola, it's always symmetric, so on the other side of the vertex, it's also going to have the same point. Okay, so both of those points we know. Then going to 1, so I'm going to fill in 1, so it's going to be 1 plus 1 squared. So inside the brackets, 1 plus 1 is 2, 2 squared is 4, 4 times -4 is -16. Okay, and then on the other side, -16 as well. So I got those points. So let's plot these two here first. So at -2 we are down at -4, and then at 0 we are at -4. Okay, if I try to plot, say, this point 1 and -16 and -3 and -16, the -16 is way down, so it's not going to fit on my graph. Okay, so I got all my points that I can, and then I can draw my parabola. Make sure you put your arrows on the end to show that the parabola just keeps going downwards. Okay, so we got the graph, but we had to label the vertex and the axis of symmetry. So let's just put those on there. So right there, we said that was our vertex. So our vertex was -1 and 0. And then the axis of symmetry actually just goes straight through the vertex. Okay, and it's always drawn as a dashed line. And then put arrows on the end to show it just keeps going up and down. Okay, so we're on to the next page here, and we are going to do number 4. So number 4 says, suppose a sculptor wants to create a parabolic arch with a height of 5 meters and a width at the base of 8 meters. So what that's going to look like is, let's say this is the ground, our arch is going to go something like this, and it had a height of 5 meters, so it goes as high as 5 meters, and the base is a total of 8 meters. Okay, so I know halfway into the middle, that distance from there to there, that's going to be 4 meters, and that's going to be important. So part A, it says determine the quadratic function that represents the arch if the vertex of the parabola is at the origin. Okay, and the origin, that's just the point 0, 0. It's the very, very center of your graph. Okay, so I'm going to draw the picture of this graph with it centered at the origin. So that's my x-axis, y-axis. Okay, and I'm basically going to take this picture and I'm going to kind of put it onto here. So it's got to go like this because we said that the vertex had to be at the origin. So my vertex is here at the origin. So that's at 0 and 0. And I'm just going to plot on some points here. So I knew that it went 4 over to get down to this base. So I'm going to go 4 over, and then down, I had to go down 5 meters. So I'm going to do that. 4 over, down 5. So that's 4, and then this is down 5. Okay, and then same way going this way, except it's -4. So I got some points that I know. I know those 2 points right there. This is at 4 and -5. Okay, so let's write the quadratic function. So I'm going to start with vertex form because we were given the question and it involved the vertex, so that's going to be easiest. Okay, and then I'm going to plug in the vertex. So that was at 0 and 0, so it's going to be x minus 0 squared plus 0. And then I'm going to simplify that. So really simply, we just got y equals a times x squared. But I need to find that a. So to find that a there, we need to use a point. And in this case, I'm going to use the point right here for -5. Okay, where that's x and that's y. So I'm going to take my work and I'm just going to write it up here. So the y is becoming -5, and then we had a times x squared, and x is now 4. Okay, so I got that. I can go 4 squared is 16 times a, so we get 16a, and then divide both sides by 16, so I get a is -5 over 16. Okay, and now that I know what a is, I can just take a and plug it into where we had it here. So my final answer is going to be -5 over 16 and then x squared. So again, all I did was I took a, put it where a was, so it's y equals -5 over 16 x squared, and that's what I wrote here. Okay, on to part B. It says determine the quadratic function that represents the arch if the origin is at the lower left end of the arch. So now the origin is going to be at the lower left end of the arch. So I got to take my graph and I got to write it so that it's like this. So let's draw a picture of that. Okay, so here's my arch starting at the lower left end. I knew that the distance between one side to the other was 8, so all the way over to here is going to be 8. I knew that halfway was 4, and then it went to a height of 5. So I know my vertex is at 4 and 5. And I know some points. I know the point 0 and 0. And I also know this point here, which was at 8 and 0. So again, we start with vertex form because the information we're given is in vertex form. Then we're going to fill in the P and the Q. So that was the vertex, that was 4 and 5. Okay, and then again, we got this A missing, and we're going to have to use a point like we did in this one. We got 2 points to choose. I got 0 and 0 or 8 and 0. Now, I could use either one, but 0 and 0 is going to make calculations way easier. Whenever you're using zeros, makes it easy to add 0 times by 0. It's always easier than using, say, an 8. So I'm going to use the zeros. So y changes to a 0, and the x changes to a 0. I'm going to bring my work up there. So I got 0 equals a, and then in brackets, 0 minus 4 is -4. -4 squared is 16, and then 16 times a is just 16a. So I got 16a there, and then plus 5. Okay, so to solve this, subtract 5, subtract 5s, the 5s are gone, and then divide both sides by 16. So I get a is equal to -5 over 16. Okay, and we actually just got the same answer. So regardless of where your vertex is, if it's at some point here or at some point here, the a value is always going to be the same, which is kind of nice. So you can just kind of use that, or if you forget, you could just work it all out and then you get the same thing. So we just got to write our function here now. A is -5 over 16. Then we had x minus 4 squared plus 5. Okay, so there's the answer for that one. I'm just going to slide this over. So lastly, part C, it says explain the similarities and differences between your two functions. So one thing we noticed was the a was the same for both. So the a value doesn't change. And then the q and the p that we had, or the p and the q, those changed depending on the vertex. Okay, so we're done with number 4. On to number 5. And number 5 says state the x-intercept and y-intercept of each function. And we're going to do A. So to find the x-intercepts occur where y is equal to 0. So I'm going to set y equal to 0 in this and then solve for x. So that y right there, I'm going to change it to a 0. So I got 0 equals x squared plus 2x minus 8. Okay, and then to solve this quadratic, what we need to do is factor. So we need to do the product and the sum. Product is negative 8. Sum is positive 2. And then the two numbers that do that are 4 and negative 2. Okay, so this breaks apart. I got x plus 4 and x minus 2. Okay, and then I'll take each of those and set those equal to 0. So x plus 4 equals 0. I'm going to subtract 4 on both sides. So x equals negative 4. And then I'll do the same thing with the other one. So x minus 2, set that equal to 0, and then add 2 onto both sides. And we get x equals 2, because those 2 canceled, just like how these 4's canceled up there. So my x-intercepts, I'm just going to write up top, they're going to occur at negative 4 and 0, and 2 and 0. And that was again because the y is 0. So y has to be the 0. X's we just found. To find the y-intercept for this one, this is going to be a little easier, a little quicker. That's when x is equal to 0. So here I'm going to change the x's to be 0. So y is going to be equal to 0 squared plus 2 times 0 minus 8. So we just get y equals negative 8. Another way to do this is whatever this last term is, that's going to be your y-intercept. As long as it's written in standard form, which it is, this is going to be your y-intercept. So our y-intercept is at 0 and negative 8. Okay, for number 6, it says determine the x-coordinate of the vertex of each of the quadratic functions. So the x-coordinate of the vertex. Now we had learned in our notes that the x-coordinate of the vertex is going to occur at minus b over 2a, where this is a, b, and c. So our minus b, it's going to be minus, and then b is a positive 6. And then in the denominator, we got 2 times a, and a is a 2. Okay, so that's going to give me negative 6 over 2 times 2 is 4. And then if I simplify that, that just gives me negative 3 over 2. Okay, so that one wasn't too bad. Goes by quick as long as you know this. Got to remember that. X equals negative b over 2a. Okay, on to 7. State the equation of the axis of symmetry and the direction of opening for each quadratic function. So this one's going to be similar again, because the axis of symmetry, that happens at the x point of the vertex. And I know the x point of the vertex is just minus b over 2a. So again, we got a, b, c. So we got minus, and then b is minus 5, so it's minus minus 5. And then 2 times a is a minus 0.5. So simplifying that in the top, those two negatives will give me a plus 5. In the denominator, 2 times negative 0.5 is negative 1. So that is going to give me x is equal to negative 5. So we got our axis of symmetry. Then we just had to state the direction of opening. And in this case, the a is negative. It's at negative 0.5 there. So a is less than 0, or meaning it's negative. So therefore, it's going to open downwards. So that one is done. Now we're going on to 8, and for this one, we are going to do part C. So in 8, it says write each function in vertex form, state the domain and the range. So what we're given here first, this right here, that is standard form. So if we are going from standard form and we want to get to vertex form, to do that we needed to complete the square. So that's all we're doing for this. So step 1, if there's something in front of the x squared, you got to pull that out. So we'll factor out the 2. And we also have to pull it out of the middle term. We do not pull it out of the last term though. Okay, if you pull it out of the last term, bad things are going to happen. So only pull it out of the first 2. Okay, then we had to take this term and we needed to divide that by 2 and then square it. What this was doing was it was creating a perfect square trinomial that I could then factor later. So when I do that, that's going to give me 16. So I'm going to put 16 back in there. I'm going to put the plus and the minus. So plus 16, minus 16. And the reason I had to do the plus and the minus was so that I wasn't changing it from this step to this step. This is the exact same function because these two things would cancel out, and then that would just give me back this. Okay, so it hasn't changed. Our next step that we needed to do though was we needed to distribute to that negative to bring that out. So when I do that, I'm going to get y equals 2 times x squared minus 8x plus 16, close my brackets, and then when I do that distribution, that's going to bring me a negative 32 outside plus 22. Okay, and then my last step I'm just going to put up over here. Just going to write the start of it. So all I do is this x term, it's going to come down, so it's going to come and go in there. Next, the sign is going to come down and go in. And then this 8 is going to come down, and when it comes down, it is going to be divided by 2. So 8 divided by 2 will give us a 4. Okay, and then the last thing, we just got to add those two terms together there. So that is going to give us negative 10. So now that we have that, we can do the domain and the range. Domain is always the same. X, given that x is an element of the real numbers. And then the range depends on the vertex and whether it points up or down. So A is positive, so it's going to point upwards. So it's going to look like that. So everything has to be above that minimum point. So Y is going to be, Y is given that it is greater than or equal to that low point, and the low point was that point right there, negative 10. So we got negative 10, and then y also has to be an element of the real numbers. Okay, looking at number 9 now. This one says the profit P earned from a sale of a particular product by a business is given by, and then we're given this function, where D is the number of days the product has been for sale. So part A, determine the vertex of the profit function. So this is going to be same as number 8. We're going to have to take this standard form and go to vertex form to figure out what the vertex is. So we're just completing the square. So let's start by factoring out that first number. And it only gets pulled out of the first two terms. So I got d squared. And then if I take 5 and divide by negative 0.25 to factor that out, that's going to give me negative 20. So I got minus 20 d and then plus 80 at the very end. Okay, then I take this middle number, I'm going to take that and divide by 2 and then square it, and that's going to give me 100. So negative 0.25 d squared minus 20d plus 100 minus 100 and then plus 80 on the outside. Okay, and then in our next step, we got to distribute this term to that negative term. That's going to bring it out. So negative 0.25 times negative 100 is going to bring out a positive 25. And then in the same step, I'm also going to bring down the d, I'm going to bring down the minus, and then this 20 is going to get divided by 2. So I got p equals negative 0.25. Just the d comes down, minus comes down, 20 comes down, and divide by 2. So that gives me 10. And then on the outside, we had the 80 plus, remember we said 25 was going to be coming outside, so it's 80 plus 25. That's going to give me 105. So I can see from this, my vertex is going to be at 10 and 105. So part B now says, explain what the vertex means in the context of this problem. So we had found the vertex, and I knew that it was a function of P and D. So this is D, and this is P. And we knew that D was for the number of days, it said, after it has been for sale, and P was the profit. So what this means is that after 10 days, we're going to have a profit of 105. That could be dollars, or it could be $105,000. We don't know. But this is at the vertex also, so that's going to be the max amount of profit. Okay, so let's write that down. Okay, so we're all done with number 9. Going to move on into number 10 here now. And both of these questions here, these questions are both going to be really important. So make sure you do know how to do these questions. Okay, so looking at number 10, it says a student club is planning a fundraising car wash. Last year they charged $10 per vehicle and they washed 120 vehicles. They would like to earn more money this year. For every $1 increase in price, they know they will wash 5 fewer vehicles, which makes sense. If you're going to increase the price, less people are going to come and get their car washed. So part A, write a quadratic function to model this situation using V as the number of vehicles and R as the revenue. Okay, so R, whenever you have any type of revenue question, revenue is always equal to your price times the number of items that you sell. Okay, so in this case, the number of items in our case, it was just vehicles that we were washing. So R is going to equal, and then the price, it originally stood at 10 bucks. And then the number of items, we had 120 vehicles. But then we went ahead and we were going to change that. We were going to increase the price by $1. So it's now going to be 10 plus $1. And then we got to put V to represent the number of vehicles, because you're going to be getting $1 more per vehicle. And then for our number of items, it was the vehicles. We started with 120, but then we're going to go down 5 vehicles depending on how many times we do this. Okay, so 120 minus 5V. So every time I increase the price by $1, we're going to lose some minus 5 vehicles. On to part B, it says determine the best price to charge for the car wash and the revenue expected at that price. So the best price is always going to occur at the vertex. We did that in our last lesson. Okay, so to find the vertex, we need to take this right here and convert that into vertex form. So in vertex form, the way we did that was we completed the square. So we got to start with this and then change it to standard form and then go from standard form to vertex form. So I'm first going to FOIL everything out. So I'm going to have, say, 10 times 120. That's going to give me 1,200. Then I'll have 10 times negative 5v. That is going to be negative 50v. Then we got 1v times 120. That's just 120v. And then we got 1v times negative 5v. That is just negative 5v squared. Okay, my next step, I'm going to put these two together, and then I'm also going to write the negative 5v squared first. Now actually what I'm going to do, rather than continuing down this and getting to vertex form, I could do that, but I'm going to show you guys actually a quicker way that we could do it. I knew that the vertex was going to occur at negative b over 2a. So if I wanted to find the vertex, and again this is v just stands for vehicles, but I'm going to use this because it's going to be a lot quicker. So this is the a, the b, and the c. I could have continued and completed the square, but this will also work. So that's going to be minus, and then b is 70. And then I got 2 times a, and a is negative 5. So those negatives will cancel. And I got 70 divided by 10, and then that's just going to equal 7. Okay, so I know that v is equal to 7, and we wanted to find what the best price was. And if we look back up here, our price was this 10 plus 1v. So the price is equal to $10 plus a dollar increase times v. And I now know what v is. So it's just a 7, so I'm going to plug that in. So that's going to be 10 plus 1 times 7, so that's just 10 plus 7, and I'm going to get 17. Okay, so the best price is going to be $17. Okay, so I got the price, I'm just going to move that up. The number of cars that we were going to wash would be this right here. It was 120 minus 5v, so that's 120 minus 5 times v, and v was just 7. And 7 times 5 is 35, so it's just going to be 120 minus 35. So that is going to equal 85 cars. And then to answer the question it wanted, expected amount of revenue, if I take the price and I times by the number of cars, that's going to give me my revenue. So my revenue will just be multiplying those two numbers. Okay, and I get $1,445. So that's how much money they would make. And then again, this right here, that was the price that we'd have to have in order to reach that max revenue.